Welcome to this explainer. Okay, so what if everything you learned in your high school science class about the universe was just completely wrong? For decades, we've been told a very specific story about how our cosmos works and why it's expanding. But what if the fundamental lens we've been looking through has been distorted this entire time? Today, we're going to look at some absolutely groundbreaking new research that suggests the biggest ghost in the cosmos might just be a massive mathematical illusion.
Now, if you followed astrophysics even a little bit, you already know that our universe is expanding, and it's doing so at a speed that actually gets faster every single day. To explain this, scientists have basically relied on a magic placeholder word, dark energy. According to the standard theory, a staggering 68% of our entire universe is made up of this invisible, completely unknown, and undetected force. I mean, think about that. It's the dominant slice of the cosmic pie, completely overshadowing all the normal matter and energy we can actually see and measure.
Section 1, the Great Dark Energy Mystery. Let's dive right into this cosmic flaw.
Okay, so here's the thing. There has literally always been a massive flaw hiding in the standard model. The physics of the very large, cosmology and gravity, and the physics of the very small, quantum mechanics, they completely clash. When it comes to dark energy, the numbers simply don't add up. It's left scientists scratching their heads for years, trying to force a puzzle piece into a hole that it clearly doesn't fit into. So I really want you to think about this for a second. What if this 68% of the universe simply doesn't exist? Just imagine if the very foundation of modern cosmology, this phantom force we've spent billions of dollars and decades of research trying to track down, has been completely wrong this whole time. If dark energy isn't pushing the universe apart, then what exactly are we looking at through our telescopes?
Section 2, a new twist in the cosmic game. Let's look at the new research. Well, a massive twist in the cosmic game has just been brought forward. Physicist Savas Koushiapas from Brown University has presented some phenomenal new research that offers a completely different explanation. And this isn't just a minor tweak to the equations, it's a fundamental rethinking of the fabric of reality itself. Now, what's really interesting about this research is that it suggests what we've been labeling as dark energy is actually a quantum change in the universe's geometry. In plain terms, we might have been looking at the universe through the wrong lens entirely. We've been frantically searching for this hidden stuff or some mysterious force acting inside the universe, when in reality, it's the structural shape and fabric of the universe itself that's shifting on a quantum level.
And this brings us directly to a concept called quantum gravity. Now, this is pretty much the holy grail of physics. It's like finally finding that missing corner piece to a giant, insanely complex puzzle you've been working on for a century. It's a theoretical framework that finally connects those erratic rules of quantum mechanics with the massive, predictable cosmos. If this new research holds up, it could explain the expansion of the universe perfectly, without ever needing to invent something like dark energy. And honestly, what's even more thrilling is that this could be the very first actual observable proof of quantum gravity happening right in front of our eyes, hidden in plain sight this whole time.
Section 3, quantum uncertainty in the universe. Let's scale things up. To truly grasp how a quantum effect can stretch across billions of light years, we have to look at how uncertainty operates on a massive, universe-wide scale. We usually think of quantum physics as something that, only applies to microscopic particles, right? But what happens if we scale those bizarre rules up to the size of the entire cosmos? In quantum mechanics, there's this fundamental rule that you cannot perfectly measure two connected properties at the exact same time, like a particle's exact position and its exact speed. Well, this new model applies that exact same rule to the cosmos. It basically states that you cannot perfectly measure both the exact size of the universe and its exact rate of expansion at the same time. There is just this inherent, unavoidable fuzziness built right into the universe's geometry.
So, the crucial point here is that because of this massive quantum fuzziness, cosmic uncertainty creates the illusion of acceleration. Our measurements make it look like the universe's expansion is speeding up, but we've been looking at this fuzzy, uncertain geometric data and falsely assuming it's being driven by an outside, unseen force. The acceleration isn't actually a physical push at all, it's a quantum illusion. Basically, it's an incredibly convincing cosmic magic trick.
Section 4, a challenge to the Big Bang Theory. Time for a cosmic rethink.
But the suspense of this incredible new research doesn't end with just deleting dark energy from the textbooks. It actually fundamentally challenges everything we thought we knew about how the universe began in the first place. I mean, we're all familiar with the standard Big Bang Theory, right? The universally accepted idea is that absolutely everything in existence started from a single, infinitely dense, tiny point, which then exploded outward. It's the starting line of time and space as we know it, but if the universe's geometry operates under these newly proposed quantum rules, that tiny starting dot might never have existed at all.
And this brilliantly illustrates a completely new timeline. Instead of a single starting dot, I want you to imagine a giant cosmic rubber band. The research proposes a three-step cycle. Step 1, there was actually an older universe that was collapsing and shrinking inward. Step 2, because of quantum geometry, it couldn't just shrink into nothingness forever, so it snapped back and triggered a cosmic rebound, which is often called the Big Bounce. And finally, Step 3, that bounce created the expanding universe we live in today. So we aren't the result of a spontaneous bang from nothing, we're actually the echo of an older, collapsing universe bouncing back. Mind-blowing, right?
Section 5. The final test of the mystery. How we actually solve this.
Now, as much as I love exploring these mind-bending concepts, we definitely have to remain objective here. This is a proposed model. It's not yet established fact, and there are absolutely still mathematical puzzles that need to be resolved. It radically challenges the status quo for sure, but it needs proof. Well, the good news is, we won't have to wait in the dark for very long. Massive cutting-edge observatories like the DESI project and the Euclid Observatory are currently out there mapping the universe with unprecedented precision. The space data they're collecting right now will serve as the ultimate final test for this quantum geometry model. It's going to either prove this incredible theory right or definitively disprove it.
Which really leaves us with this massive, provocative question. Are we about to witness the end of dark energy? If the data from DESI and Euclid actually aligns with this new quantum model, the chapter on dark energy could be closed forever. We'd have to rewrite the textbooks, reframe our entire understanding of reality, and look up at the night sky with a completely beautifully new perspective on the cosmos. I mean, it is just an incredible time to be watching the stars. Thanks so much for joining me on this explainer, and I will see you next time.